Sequence-to-sequence forecasting in Python, beginner guide. Ready to predict the future? In this lesson, you will learn how to teach Python to forecast time series data using a step-by-step approach. We will use real-world examples like retail sales and weather. By the end, you will build a small forecasting model on your own. Let us explore the basics and have fun while learning. Running the cell now. Let us get started and see what we can do with a few lines of Python. What is sequence-to-sequence, sec-to-sec, forecasting? Sec-to-sec forecasting means using data from the past to predict a whole sequence of future values. Think of it like guessing the next day's weather based on what you observed this week. Running the cell now. Does this sound exciting? Get ready for hands-on examples. We need to prepare the Python environment first. These lines help us avoid distracting warnings and load the basic tools we will use. NumPy lets us handle numbers fast. Pandas is for working with tables of data. Matplotlib helps us draw charts easily. Running the cell now. You can practice by importing these on your own for any data science project. Now let us load a real retail sales dataset. We will forecast monthly shampoo sales. The next line loads the data directly from the web. This shows how many rows and columns we have. We print the first part so you can see what the data looks like. Now you know how your data starts. Running the cell now. Try loading a CSV file from another URL later for practice. A quick plot helps us spot trends and changes. We make a bigger image for clarity. We draw the sales values as a line. The title lets us know what we are looking at. The x-axis notes months. And the y-axis is for sales numbers. Now you can spot their ups and downs visually. Running the cell now. Try drawing a chart for your own favorite dataset at home. What is a time series? A time series is just a list of values measured over time. Examples are daily temperatures, monthly sales, or yearly profits. We can use time series like a diary for numbers. Running the cell now. Sometimes column names or missing values can cause errors. Let us rename columns to lowercase for easier typing. This line makes sure sales values are treated as numbers only. If there is any missing data, we drop those rows now. Here is a look at the clean data. Running the cell now. Clean data helps avoid small mistakes later. To forecast more than one step at a time, we need to make input and output sequences. This function will turn our data into short sequences. We make empty lists to hold inputs and outputs. Go through the data and grab chunks. Take a chunk of past sales as X. Then take the next future sales as Y. Return arrays so we can use them for learning later. Turn the sales column into a simple number list. Now we use our function to get sequences of 3 months to predict the next 2. Let us check the size of our inputs and outputs. Running the cell now. Can you try the function with different input and output sizes? Getting a peek at our data pairs helps us feel confident. Let us print a few sample input and output pairs now. Each input array is a short history. Running the cell now. Try saying out loud what each pair means in real time. To check if our model works, we need to test it on unseen data. This line imports the tool to split our pairs. Here we split into training and test sets. 20% goes for testing and the rest for training. Do not worry about random results, the setting keeps it steady for all of us. How many sequences will our model learn from? How many will we use for checking predictions? Running the cell now. Try changing the test underscore size later to see what happens. Let us use linear regression to predict our sequences. We import the tool from scikit-learn. Start by making a model object. First, we flatten the input sequences to one long row each. Also flatten the outputs to match. Now fit or teach our model using the training pairs. Running the cell now. This approach works for simple problems and is a great place to start. Now let us use our model to predict sales it has not seen before. We have to flatten the test inputs just like training. The model predicts next sales numbers for each input. Let us print the first 3 predictions against the true values. You can see how close our guesses are to the actual results. Running the cell now. Notice any patterns? Try more predictions to improve your instinct. A picture shows how well we predict compared to truth. Set up the plot size. Draw a line for the actual first predicted month. And another for our model's guesses. Label your chart for context. A legend helps us know which line is which. Now you can spot where our predictions were strong or weak. Running the cell now. Try plotting for the second predicted month as extra practice. We need a way to score how good our predictions are. Here we import a basic tool for measuring mistake size. This line computes average square difference between guess and truth. Print out the score with 2 decimals for easy reading. Running the cell now. Lower errors means better forecasting. Can you beat this score later? Recap: you built a sequence-to-sequence forecaster. You loaded and cleaned real data. Turned it into input and output sequences. Trained a simple model. Scored how well it predicted. Let us try a real-world challenge next. Running the cell now. What could you forecast in your own life with these ideas? Let us let you try the model for yourself. Now Python waits for you to type 3 sales numbers. We split your answer into a neat list. The model needs it as a number array. Ask the model to make its next guesses. Print your input for checking. Here is what the model thinks comes next. Running the cell now. Pause and try your own numbers. Notice how the answers feel realistic? If you like this style, subscribe and give us a like. We have more forecasting tips coming. Let us take this further and build a simple project. Use the last year of our real data. Keep only the 3 most recent months as our new input. Forecast using your trained model. See what those last 3 months were. Here is our model's guess for the coming 2 months. Running the cell now. Practice forecasting with data from your favorite business or activity. Let us try a different challenge. What if you use 6 months instead of 3 for each prediction? Create new input-output pairs with a bigger window. Split into training and test again. Build and fit a new model for these pairs. Check how the new model learns. Score the new model on unseen test data. Now compare your accuracy to the older, smaller sequence model. Running the cell now. Remember to compare results. Did more history help? If you want to go beyond basics, here is a stronger model. Random forest mixes up many decision trees for better forecasting. Train the new model on our existing pairs. Predict the outputs for our test set. Score the predictions as before. Did this method beat simple linear regression? Running the cell now. Feel free to explore more model types in your own time. If things do not work, often it is just shapes being different than expected. Let us print out the size of each important variable. Training inputs. Training outputs. Testing inputs. Running the cell now. Compare these sizes if you see errors. It helps spot mistakes fast. Let us encourage you to experiment. You did it! Ready for your challenge? Change the number of steps to predict output_size in the earlier function. Plot both the first and second month's predictions. Try this on another open time series dataset. Let us see your results in the comments. Running the cell now. Can you invent your own forecasting challenge? Recap and next steps. Today you learned to load and clean time series data, create input-output sequences, train and test models in Python, score your forecasts and make improvement. You are now ready to explore deeper forecasting ideas. Like this video? Subscribe for more Python and AI lessons. Running the cell now. Thank you for learning with us. Keep going and try your own projects. See you next time.